There's a star out there so incomprehensibly massive that light itself takes over 6 hours just to travel around its equator. If you placed it where our sun sits right now, its surface would swallow Mercury, Venus, Earth, Mars, Jupiter, and keep going until it nearly reached Saturn. But here's the problem. If you search for the largest star right now, you'll find a mess of conflicting answers. Stephenson 218, Uy Scuti, Vy Canis Majoris, the internet can't seem to agree, and that's because until very recently, neither could astronomers. If you're fascinated by cosmic mysteries like this, hit that like button, subscribe, and ring the notification bell. We explore the universe's biggest secrets every week. For years, the internet crowned Stephenson 218 as the undisputed champion, a star allegedly 2,150 times wider than our sun, so large it would extend past Saturn's orbit. Videos went viral, infographics spread across social media. It became astronomical gospel. But there was a problem, a big one. In the 1960s, Japanese astrophysicist Chushiro Hayashi discovered something fundamental. There's a limit to how large a star can physically grow. It's called the Hayashi Limit. When a star gets too big and too cool, it can no longer hold itself together. The physics simply don't allow it. For stars in our galaxy, this limit sits around 1,500 times the sun's radius. Anything claiming to be dramatically larger is breaking the laws of thermodynamics. Then came Gaia. The European Space Agency's revolutionary telescope measured the positions of nearly 2 billion stars with unprecedented precision, and Gaia's data delivered a verdict. Stephenson 218 isn't moving with its supposed cluster. It's going a completely different direction, which means it's probably not 20,000 light-years away at all. It's likely a foreground star, much closer and much smaller than anyone thought. There's another problem. The way we measure stellar size depends heavily on temperature. Get the temperature wrong, and your radius calculation explodes. Stephenson 218 was assigned an unusually cool temperature of 3,200 Kelvin. But much of that apparent coolness was likely interstellar dust reddening the light. The star was probably never as cold or as impossibly large as claimed. Uy Scuti suffered a similar fate. For years, it held the record at 1,708 solar radii, but Gaia's parallax measurements placed it much closer than previously thought. Closer distance means lower intrinsic brightness. Lower brightness means smaller size. The revised estimate? About 909 solar radii, still enormous, but no longer a record breaker. So who actually wears the crown? Me RSGC1, F01, a red supergiant in the Scutum Crux arm of our galaxy, about 22,000 light-years away. Its radius? Between 1,430 and 1,530 times that of our sun. Right at the edge of what physics allows. And crucially, its cluster membership is confirmed. Multiple stars in the same cluster show the same size limit. This isn't measurement error, this is nature's ceiling. Let that sink in. RSGC1 F01 is over 1 billion kilometers across. Light, traveling at 300,000 kilometers per second, needs 6 hours and 12 minutes just to complete one lap around its equator. If you could somehow fly around it at the speed of a commercial jet, it would take over 1,100 years. This star makes our sun look like a marble next to a stadium. Vy Canis Majoris deserves mention. At 1,420 solar radii, it's a reliable runner-up with one of the most precise distance measurements in astronomy, thanks to water masers in its atmosphere. Westerland 126 is essentially tied with RSGC1 F01, though its dusty environment makes measurements trickier. These titans cluster around the same size, right at the Hayashi limit. The universe seems to have a hard cap. Here's a question for you. If you could visit a planet orbiting one of these monster stars, how different would that sky look? Would the star fill your entire horizon? Drop your thoughts in the comments. But the most dramatic story belongs to WOHG 64. located 160,000 light-years away in the Large Magellanic Cloud. In 2024, the Very Large Telescope captured something extraordinary. This star isn't just big, it's transforming, dying in real time. New observations reveal WOHG 64 has evolved from a red supergiant into a yellow hypergiant. Its surface temperature is rising, its radius is shrinking, and the reason? It's a binary system. A companion star is stripping away its outer layers, accelerating its death spiral. The images show an egg-shaped cocoon of dust, nearly a light-year across, the shed skin of a star preparing for its final act. What happens next will be spectacular. WOHG 64 will explode as a supernova, possibly within our lifetimes. That dusty cocoon will be flash ionized by the shockwave, creating a light show similar to SN 1987A, but on a grander scale. Astronomers have a front row seat to stellar death. We're watching a titan take its final breaths. Why does any of this matter? Because these dying giants are cosmic forges. Every element heavier than iron, the gold in your jewelry, the calcium in your bones, was created in the death throes of stars like these. Understanding how large they can grow tells us how they live, how they die, and how they seed the universe with the ingredients for planets and life. The hunt continues. The Nancy Grace Roman Space Telescope and the extremely large telescope will soon peer through the dust clouds obscuring the Milky Way's inner regions. They may find stars that push even closer to the Hayashi Limit, or exotic objects that challenge our understanding entirely. The largest star is a temporary title. Someone always gets dethroned. But here's the real takeaway. Stephenson 218's fall from grace isn't a failure of science. It's science working exactly as intended. We made measurements with the tools we had. Better tools came along. We corrected our mistakes. That's not embarrassing. That's the point. The universe doesn't care about our viral infographics. Physics has rules. And when we listen carefully enough, nature tells us the truth. RSGC-1, FO1 sits at the edge of what's possible. A star so vast it touches the boundary between stability and chaos. 1,530 times wider than our sun. Over 1 billion kilometers of churning plasma. And somewhere, around one of its distant neighbors, there might be worlds looking back at it, wondering the same things we wonder. How big can the universe make something, and what does it mean that we're small enough to ask? If this made you feel appropriately tiny, leave a like, subscribe, and ring that notification bell so you don't miss our next deep dive. We're exploring what would happen if a magnetar appeared near Earth. Trust me, you'll want to see that one. Until then, keep looking up.